All right, so next we're going to start looking at the remainder theorem. So the remainder theorem says that when a polynomial f of x is divided by a linear expression x minus lambda, the remainder is f of lambda. When a polynomial f of x is divided by a linear expression x minus lambda, the remainder is f of lambda. All right, now of course we can probably show that this is true. Now, as you saw in the previous example, I can go back up a little, that if you divide a polynomial by a linear expression, so that's what we did here. We divided a polynomial by a linear expression. What we got was to the right, we got back another polynomial plus some remainder over the linear expression I'm dividing by, which is x plus 1. All right. So if I divide f of x by this linear expression x minus lambda, I'm going to get some other polynomial. Let's just say that is q of x plus, let us say, a remainder over x minus lambda. Sorry, based on the example we did before, this is what happens. If I divide a polynomial by a linear expression, I'm going to get a polynomial plus some remainder over the divisor, which is x minus lambda. Now, again, if I multiply now both sides by x minus lambda, so I have x minus lambda multiplied by f of x over x minus lambda is equal to q of x multiplied by x minus lambda, because I'm multiplying the entire equation by x minus lambda, r over x minus lambda by x minus lambda. I'm multiplying the entire equation by x minus lambda. So of course, x minus lambda cancels x minus lambda here, and x minus lambda cancels x minus lambda over to the right as well. So now what I have is f of x is equal to q of x multiplied by x minus lambda plus some remainder. Now, if x is equal to lambda, if x is equal to lambda, I'm going to get f of lambda, because remember, x is equal to lambda, is equal to q of lambda, because x is equal to lambda, lambda minus lambda plus the remainder. So if x is equal to lambda, I'm going to get f of lambda is equal to q of lambda. Remember, x is lambda, so I'm going to have x minus lambda plus the remainder. Now, lambda minus lambda is 0. And if you multiply q of lambda by 0, once you multiply anything by 0, you're going to get 0. So what I'm going to have is that f of lambda would be equal to 0 plus the remainder. And 0 plus the remainder is just the what? Remainder. So this essentially is sort of like a little proof for the remainder theorem, that if I divide a polynomial f of x by a linear expression x minus lambda, the remainder is f of lambda. And we just showed it to be true. All right, let's just see this in action. Don't worry about writing this off just now. You can write it off when I send it to you later. Let's try and see it in action before we leave, or before the class ends. All right, so here's what the remainder theorem says. If I divide f of x by x minus lambda, the remainder is equal to f of lambda. That's what the remainder theorem says. Now, what I want you to notice is that whatever is the sign of lambda in the divisor, when you find in f of lambda, the sign changes. So down here, let me try and change the color ink for emphasis. It's minus lambda, but in the remainder, I have what? Plus lambda. All right. So in this case now, I'm dividing, this is minus 1. So the remainder would be equal to f of 1. All right. So let's see if I see it in action now. Another way to do it is you could do this to say that if you have x minus 1 is equal to 0, and to say x is equal to 1. So the remainder would simply be f of 1. That's another way to look at it. But the easiest way is to say that if you're dividing by x minus 1, the remainder is f of 1. If you're dividing by x plus 2, the remainder is f of minus 2. All right? So let me just try and show you what this is saying. Example 12 is saying, find the remainder when f of x, which is equal to 4x cubed minus x squared plus x minus 2 is divided by x minus 1. So from the remainder theorem, looking at A, if f of x is divided by x minus 1, the remainder would be equal to f of 1. So we're asked to find the remainder. So the remainder, which is f of 1, for f of 1, in f, wherever I see x, I'm going to simply replace x with 1. So this would be equal to 4 times 1 cubed minus 1 squared plus 1 minus 2. Again, the remainder theorem says, if I divide f of x by x minus 1, the remainder is going to be f of 1. All right, so let's find the remainder. This is going to be 4 times 1, because 1 cubed is 1, minus 1 squared, which is 1, plus 1 minus 2. This is 4 minus 1 plus 1 minus 2. 4 minus 1 is 3. 3 plus 1 is 4. And 4 minus 2 is 2. So according to the remainder theorem, if I divide f of x by x minus 1, the remainder is f of 1, which is equal to 2. Any questions and or comments? All right, so there are no more questions or comments. So let's go to B. For B, f of x is divided by, so in B, f of x is divided by x plus 2. So the remainder is going to be equal to f of minus 2. So if it's plus 2 in the divisor, for the remainder, it's going to be minus 2. Now, the remainder, which is f of minus 2, in f, wherever I see x, I'm going to take out x and put minus 2. So it's 4 minus 2 cubed minus minus 2 squared plus minus 2 minus 2. So you want to be careful not to make any errors. This is 4, minus 2 cubed is minus 8, minus 2 squared is minus 2 times minus 2, which is positive 4, so it's minus 4. A positive times a negative is a negative 2. minus 2. So what I have here is minus 32, minus 4, minus 2, minus 2. So it looks like the remainder is minus 40. So if f of x is divided by x plus 2, according to the remainder theorem, it is equal to minus 40. The remainder is equal to minus 40. All right, the last part. Now, for the last part, which is C, f of x is divided by 2x plus 1. So the remainder is going to equal to f of minus a half. Well, you could say, sir, or you get the minus a half. I told you that what you could do is that you could say 2x plus 1 is equal to 0. So then 2x would be equal to minus 1, and x would be equal to minus a half. So that's one way you could get the minus a half. So the remainder which is f of minus a half, is equal to 4 minus a half cube minus a half square plus minus a half minus 2. This would be equal to 4 times minus 1/8 minus a quarter, because minus a half times minus a half is a quarter. A positive times a negative is a negative, a half, and then minus 2. Simplifying, we have what? 4 times minus 1/8 is minus a half, minus a quarter, minus a half, minus 2. All right, it looks as if the remainder, which is f of minus a half, would be equal to minus 3 and a quarter. It's minus 3 and a quarter, or you could say it's minus 13 over 4. Minus a half is minus 1. Minus 1 minus 2 is minus 3. Minus 3 minus a quarter is minus 3 and a quarter.